In this lecture, we are going to derive a formula when we consider the Q tilde as a piecewise linear polynomial. You must have remembered that when we have Qn plus 1 or Qni is equal to 1 by delta x, xi minus 1 half and xi plus 1 half. And here, if we replace this q with q tilde, and if it is constant, then we get upwind method. This was the idea of Godunov's method. This is Godunov's method when q is q tilde, which is just a constant. But suppose that if we have a linear over here, we already discussed that when you put q tilde is equal to this linear term, which is actually y minus y1 m x minus x1. Here the sigma is the slope, xi is the cell, and this is defined as xi minus 1 half plus xi plus 1 half divided by 2. And q and I is the value of variable at cell I. We derive this for the advection equation. Equation 2 is our advection equation. We know that the advection equation has a solution x minus u bar delta t. At initial time, whatever the value is at initial time t is equal to 0, if we have sin x, then the new value or the solution can be obtained as x minus u bar t. So that's what we write over here in the equation form. Here, the q tilde shows that we are working with the Godunov's method, and n is the nth value of Godunov's method, and the solution Tn plus 1 will be equal to the Tn, and the previous solution at Tn will be written as x minus u bar delta t. Okay, so it means that the initial profile will just translate from left to right or right to left. It depends what is u bar. Okay, so that's what we write in the form of a solution. We replace this solution into equation number 1. So this x will become x minus u bar delta t, and Tn becomes Tn plus 1, and we have Qn. Then we replace this Q with x minus u bar delta t, so on. So the cell average is defined as like this. So we put the value of Qn x Tn plus 1, this value over here, which we already did. Now we know that the CFL number should be less than or equal to 1. So we split this interval, which is xi minus 1 half, and then we have xi, and this is xi plus 1 half. So we split that interval into the xi minus 1 half and 2xi minus 1 half plus u bar delta t, so on, so that the waves do not interact with each other. So we split that into the two integrals. Now we first solve the first integral, and this is our first integral over here that we are going to solve over here. And remember that one thing you should have noticed, that the q and I will change accordingly. In xi minus 1 half plus u bar delta t, we should have in this interval we should have qi minus 1, and when we have the interval xi minus 1 half to xi minus 1 half plus u bar delta t to xi plus 1 half, we should have qni. Okay, so what we do, we just put the value here. We use substitution. X dash is just a new variable, and we put the value of xi minus 1 half. Xi minus 1 half means that we are at xi, then subtract that with delta x by 2. So after solving it, we get x dash, this value over here. So the lower limit when x is equal to xi minus 1 half, this will be cancelled out. We get 0, so we have lower limit 0. When we put the upper limit xi minus 1 half plus u bar delta t over here, then we get u bar delta t after some cancellation. Moreover, the value qni minus 1 is same as it was earlier, and this will be written as x. You can write x dash plus xi minus 1 by 2 is equal to x. So this will become x minus u bar delta t as it is, and xi minus 1. We also know that xi minus 1 can be obtained as, if we just take a difference. For example, if we have xi minus 1 half and here is xi minus 1, you can reach over here by taking xi minus 1 by 2 minus delta x by 2. You can reach over here. So I1 we have, we can replace xi minus 1. This is xi minus 1 with xi minus 1 by 2 minus delta x by 2. So after some simplification, we get x bar and minus u bar delta t plus delta x by 2. So we just integrate the above integral since it is now in a simple form. This is just a constant value. The integration will be qni minus 1 x dash. Then you put the lower limit and upper limit u bar delta t. So when you put the upper limit, you get u bar delta t plus sigma ni minus 1, and integrate this variable. So we have x dash square by 2. Then we put the lower limit and upper limit u bar delta t. So this becomes u bar delta t square by 2. Similarly, this is a constant. So we have u bar delta t x dash, and we put the lower limit and upper limit. So we get u bar delta t whole square, and similarly we do the same for the last term. So we reached at I1. Now we have solved I1. Now we move to another integral. Another integral is, the second integral is this term over here. Okay. So you can just take a look on the substitution over here. The substitution is this variable. We substitute x double dash over here and change the limit. When we put the lower limit over here, we get 0. When we put the upper limit, then we get delta x minus u bar delta t, and so on. So this will be the simple form over here. Also, we notice that xi can be obtained. For example, if we have xi minus 1 and this is xi, so xi can be obtained if we add delta x by 2 into xi minus 1 half. and after solving it, we get this answer. So this is just a constant, and so we get the integration q n x double dash, and we put the lower limit and the upper limit delta x minus u bar delta t. So this becomes delta x minus u bar delta t. Similarly, when we solve this variable, so we get x double dash square by 2, and we have the lower limit and we have the upper limit minus u bar delta t. So we get this term. Then the last term is just a constant, and we get the last term over here. We put all these I2 and I1 into equation number 7. This is equation number 7. So when we put that equation number, we put I1 and I2 into equation 7, we get the answers. We put all the answers. 1 by delta x is the coefficient. We put this value, then we put this value. This is the answer of I1, and this is the answer of I2. This is the answer of I2. So we just multiply the terms. We multiply this term by 1 delta x and so on. So we solve all these equations. Then combining these two terms, this is the first term. And then we have, for example, these three terms. We combine these three terms. You can take a look at yourself. U bar delta t by delta x is taken as a common, and this is the coefficient. Now what we do, we take a common q and I in this term, and we also take some common value over here, and after some simplification you can see it yourself. This is very simple, and we reach at this equation, which is actually given to you in the book of finite volume method, and it is chapter number 6, I guess. So after some simplification, we get this answer. Here sigma is the slope. We saw that in our previous video, when we put different combination of sigma and I, we get different answer. Thank you for watching.